Hello and welcome to a measurement video on the circumference of a circle. First of all, we'll check out the parts of a circle. We have the diameter. The diameter is the distance across a circle passing through the center. So there's a circle, there's a center, and we have an interval that passes across the circle and goes through the center to the other side, and that's called our diameter. A radius is the distance from the center of the circle, just the center of the circle, to the edge of the circle. So that's going to be half of the distance of a diameter. A chord is an interval joining any 2 points on the edge of a circle. Doesn't have to pass through the center, just any 2 points on the edge of a circle. So there's your chord there. It passes through this point on the edge of the circle and this point on the edge of the circle. So that's called a chord. We have a tangent. It's a line this time touching the edge of a circle at only one point. So it goes up to the circle and just touches it at one point on the circle, and we call that line a tangent. We have a segment, and that's a part of a circle created when a chord goes across a circle. So we have a chord here, and that creates a segment section. Technically that's a minor segment that I've got here shaded, and there's another major segment here. The chord actually cuts the circle into two segments, but we'll call that one a segment, that smaller section there. The circumference of a circle is the distance around the edge. So if we started where the red marking is there and went in the direction of the arrows and went all the way around the circle back to our starting point, that distance is called the circumference of the circle. And an arc is just one little section of that circumference. So that section there that I've marked in red there is part of the circumference. We'd call that red bit an arc. We have a sector. It's an area of a circle formed by two radii, and that's just the plural of the word radius. So two radiuses and an arc, and that forms a sector. I'll show you how. We've got one radius there and another radius there, and we've got the arc that goes around. We just got through saying that a section of the circumference is an arc, so the arc's in blue there. And so that forms a little section of the circle known as a sector. So the main part of the video here, finding the circumference of a circle. The circumference can be found using one of the following two formulas. We've got a formula that has the circumference equaling 2 times pi, and I'll tell you about pi in a moment, times the radius, and we kind of summarize that by saying C for circumference equals 2 pi r. So in between things that are beside each other is an invisible multiply sign. So we'll remember that there's multiplication between the two, the pi and the r, and that r stands for radius in this case. So 2 times pi times whatever the radius is will give us the circumference of the circle. Now if we have a diameter instead of a radius given to us, we'll more than likely choose to use this second version. Circumference equals pi times whatever the diameter is. And we'll shorten that by saying circumference equals pi d, or pi times d. So circumference equals pi times the diameter. So usually if we're given a radius, we'll use the first version with the r in it. Or if we're given the diameter in the question, we'll choose to use that second version. And there's a pi in that first version, 2 times pi times r. And there's a pi in that second section, pi times d. So we'll need to have a think about, find out about pi. Pi is a very special number. It's very special to circles particularly. It helps us work out a lot of things to do with circles. Pi represents technically the number of times the diameter of a circle goes around the circumference of that circle. And it works for any circle. That the number of times the diameter goes around the circumference is the same number in either very small circles and very big circles as well. Now we usually get that pi number to use in our calculations from our calculator button, and pi goes on forever. It's called an irrational number, and it's a continuous decimal that doesn't stop and doesn't have any patterns to it either. Strange sort of a number, but very useful for circles. So we usually get it from our calculator button. But in some questions we're actually told what to use, what form of pi to use. Sometimes we use a rounded off version of 3.14, which is a shortened version of pi, or 22 over 7. An improper fraction of 22 over 7 is also very close to the decimal that we have on our calculator. So every now and again they'll tell us what we should use for pi. So here's an example. Find the circumference here of this circle, and it's got a radius of 6. Remember, the radius goes from the center to the edge, so 6 centimeters is our radius. So we might choose to use the radius version of the circumference formula here. C equals 2 pi r. Now we remember that in between the 2 and the pi and the r there's a multiply sign as well. So what we're going to do is we're going to say the circumference equals 2 times pi times 6. Now why have we put a 6 there? Well, we said that 6 is our radius up here. That's our radius, and so that 6 goes in the spot where the radius needs to go. And on our calculator we have a calculation that says that our circumference in this particular circle is 37.7 centimeters. I've rounded that off to one decimal place. So we had a circle with a radius of 6 centimeters, and that created a circumference, a distance around the edge of the circle, of 37.7 centimeters there. Okay. Now in this next circle we're given a diameter. The diameter, remember, goes from one side of the circle to the other, passing through the center. So we've got a diameter of 20 meters this time, and thankfully we have a circumference version of the formula with a d in it, d for diameter. So what we do here is we take the circumference, it equals pi times whatever the diameter is. Now 20 was our diameter, so that's our diameter, and we're putting it kind of in the spot where the d is, and calculating from there. So pi times 20 on our calculator, there's a pi button on our calculator, that'll give us a circumference of 62.83 meters, rounded off to two decimal places. When the question doesn't tell us how to round it off, we're allowed to choose, and we just tell the marker how much we've rounded it off. So we just do pi button on our calculator times 20 and then press equals. And that's the distance around this circle. A lot bigger circle, obviously, 20 meters across, so it's a very big circle. And then we have our two circumference formulas there, two examples. One of them we use the radius because we were given a radius. So this first one we were given a radius, so we use the radius version of the circumference formula. In this second one we were given a diameter, so we use the diameter version, and that's a pretty logical thing to do. So sometimes we're asked, as I said before, to use a particular version of pi in our calculations and not just take what the calculator gives us. So in this question we're asked to find the circumference of a circle below using pi as 22 over 7. So where it says pi, instead of pressing the calculator button, we'll type in 22 over 7 for that bit instead. So because it's given us a diameter in this question, I'm going to choose to use the diameter version of the circumference formula. Remember, we have a radius version and a diameter version. So we have circumference equals pi times d, and we have a diameter from our question, you'll see, of 10 meters. So that'll go where the d is. Now for pi though, they've told us to use a particular version of 22 over 7. So I'm going to take that 22 over 7 and multiply it by 10, which is my diameter. So really I've put the 22 over 7 in there instead of pi, and I've taken the 10, which is our diameter, and put it in there instead of the d, and multiplied those two things together. That's all I've done. So if I'm leaving it as an improper fraction, I'll get 220 over 7, but probably it's logical to divide that bottom 7 into the 220, or press that S to D button on our calculator and get a final answer of 31 3/7. Because we've used a fraction version of pi, because the question asked us to, we'll try and leave our answer as a fraction if we can. So one thing's interesting. I've just got through saying that if you've been given a radius, usually you use the radius version of the formula, and if you're given a diameter, you'll more than likely choose to use the diameter section of the formula. But we do have a bit of flexibility. Let me show you here. So if you've got this here, this circle with a radius of 6 centimeters, we could put that 6 straight into that radius version of the circumference formula. No problem there. We also, if we like using the diameter formula every time, we could turn that radius of 6 into a diameter of 12, because remember the radius is half of what the diameter would be. If this line up here went all the way across after heading through the center, it would have 6 on the right hand side and 6 on the left hand side. Can you see that the diameter for that circle would be 12? And if we did double that radius to get a diameter of 12, we could then choose to use the diameter version of the circumference formula if we liked using that one better. Some students remember that pi d version of the circumference formula more easily than the 2 pi r version. It's up to you really. Now if we were given a diameter of 20, we would more than likely choose to use that diameter version, but of course how do we get from a diameter to a radius? A radius, if I could draw a straight line, a radius would be half of what the diameter would be for that question. It only goes from the center to the edge, not from one side all the way through the center to the other. So we could divide that diameter in two and get 10 for the radius, and then choose to use our 2 pi r formula if that was our favorite. So if you like, you can choose a favorite and just adjust each of the questions. If you do remember both forms of the equation, though, they're both formulas, we can then be a bit more flexible about which one we use, and it's a bit quicker. We don't have to adjust if we stick to the radius version for radiuses and the diameter version for diameters. Alright, let's summarize now. We've had a look at the parts of a circle first. Many of these questions about circumference talk about parts of a circle, so we'd better know our way around circles. The diameter we've talked about. We need to know about a radius, a chord, a tangent, a segment, an arc, a sector, and a circumference. So you need to know the meanings of all those and maybe know how to draw a quick diagram. We also learnt about pi, because that pi was in both versions of our circumference formulas for finding the circumference of a circle. It's a very special number used in circle work. Usually we just get it from pressing our calculator button, but sometimes we're asked to shorten it to 3.14 or 22/7, and every now and again the question will tell us which version to use. And also, to find the circumference of a formula, we had a radius version, circumference equals 2 pi r, where we put the radius number in. Or, if we're given a diameter, we might choose to use the diameter version of the circumference formula, where we just take pi and multiply it by whatever the diameter is for that particular circle. Hope that helps. All about circles and the parts of circles. We're talking about pi there, and we learnt how to